Hey, Michaela, let's go over these problems that you missed in 104. So here we've got a graph. So let's copy this over, and I'm going to show you how you would solve that, what's going on with that. So here is the graph. So we're going to, let me get my pen. And what we're going to do is we're going to take this equation, or I should say inequality, and we are going to I'm going to solve it for x first so that we actually know what we're supposed to be doing. So to do that, I'm going to add 2 to both sides, and that gives us negative absolute value of x, because these would cancel, is less than a negative 2, because negative 4 and positive 2 makes a negative 2. We don't want to have this negative sign out here. We want to be able to have x by itself. So we're going to multiply everything by a negative 1. And that's going to make this the opposite, which is going to be the absolute value of x without the negative sign. It's going to make this the opposite sign, so it's going to go this way. And it's going to make this the opposite sign, so now it's going to be a positive 2. Now that we have the absolute value of x by itself on this side, then we can solve for both the positive and the negative. I'm going to do the negative value first. So negative x greater than 2. Now we don't want a negative x, so again, we multiply everything by negative 1. So that gives me negative times negative gives me a positive. Negative times this gives me the opposite symbol. And then negative 1 times 2 gives me a negative 2 again. And then when I do the positive value of x, I just get x is greater than 2. I don't have to do anything to it because it's already positive. So now I have that x is less than a negative 2, and x is also, it's greater than a positive 2. So these are going in opposite directions. They are opposite symbols, but because this is greater than and not less than, we cannot write this as a conjunction. We wouldn't be able to. So instead, what we're going to do is we're going to find on the number line. Let me take this back up to the top so we can see it. This is our solution. We're going to graph that solution. So you would find negative 2, and x is less than negative 2, so it's going to go this way. And we're going to find positive 2, and x is greater than positive 2, so we're going to go this way. All right, so this would be how you would graph. This is called a disjunction. And a disjunction is where you cannot combine them. You have to do them as separate graphs. All right, that's what we have here. Okay, let's look at the next one that you missed. And I think it was this one. Round pi to the nearest millionth. Okay. So first of all, you have to understand what pi is. Let me pull up my calculator. So pi is not 3.14. And this is something that I've stressed over and over again. 3.14 is pi rounded to the hundredths place. This is pi right here. And this is not all of pi. Pi goes on and on and on and on forever. It never ends. Okay, but this may be enough for us to do what we need to do. And I'm not sure, so let me go ahead. I'm going to go to Google, and I'm going to pull that up, and I'm going to say, let me go to Google first. What is the value of pi? There it is right here. What is the value of pi? And you could see it goes on much further, right? So what is the true value of pi? The true value of pi is you see this, it goes on and on and on and on and on and on and on. The way that you can get there on the calculator to find pi, let me go to here. If you have a calculator, you can find pi by saying, let me stretch this out. You could say 22 divided by 7 is also a value of pi. right? So if you need to, you can go that way and it will get you there fairly closely. But I tend to use, just because it doesn't change, I'm going to Control C, I'm going to copy that, and I'm going to take it over here and I'm going to paste it. So now I have this value of pi, and I'm going to increase it in size so we can see it. Okay, now I just need to find the millionth place. So this would be tenths, hundredths. Then this would be thousandths, 10,000ths, 100,000ths, millionths. So this is the space that we want to go to, this 2 right here. We are going to round to this space right here because this would be millionths. I don't know why it jumped down. Stretch it back out for us. So this is pi, and pi goes on and on and on and on and on and on. It doesn't repeat, and it doesn't have a pattern, and it doesn't end. So we want to round to here. This is the millionths. All right, so what we do is we look over here. Is this 5 or more? Yes, so we need to plus 1 here. So 3.14159, and this is going to round up to 3, and all of these will go away. And this is rounding this to the millionth place. So that's going to be your answer, 3.141593. And the reason most people use 3.14 for pi is because if you look right after the 4, it goes way back down to 1. So usually that's a place where you would stop, is whenever the numbers, if they had kept on going, you would round it somehow. But because it drops back down, that's a natural place to stop. So that's why we use 3.14. And 3.14 is very accurate. And it's very accurate because it drops back down in that 3rd place. But it is not the end of pi by any stretch of the imagination. So this is, pi would continue on and on and on and on and on forever and ever. But this is when, this right here is where this is what you should have put in. Doing 3.141414, that is not correct because this does not repeat, right? It's different numbers. So because it's different numbers, you have to look up what they are. And Google is one of the best places you can go for that, unless you have a calculator that will display past the millionths. So, or further. But, find that number, round it to the right place, and then you'll be okay. All right, let's look at another problem. Let's see over here. I think it was this one that you missed also. I'm going to pull this over and let's see what happened here. Okay, so we want to find the area of the green shaded portion of the parallelogram, not this gray circle. We want to take this gray circle away. So we want to find the area of the green parallelogram and then subtract this. So we're going to take the area of the parallelogram minus the circle. That's what we're going to do. And that's going to be the green area. That's our formula. So first of all, let's find the area of the parallelogram. And the dimensions are in inches. That means we're going to go 9 by 6. So 9 inches by 6 inches. And that equals 54 inches square. Now we need to find the area of the circle. And the circle has a radius of 2 centimeters. So the area of the circle is pi times the radius of 2 inches squared. So 2 inches again. 2 times 2 is 4. So this is going to equal 4 times pi in inches squared. Well, now that we have a unit of measure that is the same, we're going to subtract 54 minus 4 pi, and all of that is in inches square. And this is this. It is the parallelogram minus the circle. Usually we add because we are combining like a rectangle and a half of a circle. Well, this time we're subtracting because we're taking a circle out of a shape, kind of like a donut, right? You take the hole out of the middle of a donut. This is the same thing. We're taking the circle away, so it's subtraction. This would be the answer that I'm looking for. All right, and that was the last one. If you've got any questions, please feel free to message me back.